Hello everyone, welcome to today's class. This is Teacher Simon taking you through ASPO Mathematics paper 9709/12 for October November 2022. And this is part 1 for questions 1 to 6. Question 1 is coming from coordinate geometry. Points A and B have coordinates 5, 2 and 10, -1 respectively. Part A, find the equation of the perpendicular bisector. Now we should know that a perpendicular bisector passes through the midpoint of a line segment. So therefore, midpoint of AB, this one has to be equal to, this is 5, then plus 10 divided by 2, and then we have 2 plus -1 out of 2. This one will give us 15 over 2, which is 7.5, and then this other one will be 2 minus 1, that will be a 1, so it's a half. Remember, to find the equation of a straight line, we need one point, at least one point through which a line passes, and also the gradient of that line. Okay, so we shall need to find M1, or the gradient of AB. This one is going to be change in y, so this is -1, then -2, then out of the change in x, this will be 10, then -5. So this one will give us -3 over 5. Okay, then M2, because these two are perpendicular lines, so M1 times M2 is equal to -1. So our M2 is going to be -1, then out of 3, this -3 over 5, so giving us 5 over 3. Okay, this is the gradient of this one, perpendicular bisector. So using y minus y1, which is equal to m into x minus x1, that means we are going to have y, then our y1, we are going to use this point here. Okay, half, then the m is 5 over 3 into, then x minus 15 over 2. Even when you leave it here like this, they can give you the marks, but let us continue. We open the brackets and then we make y the subject of the formula. So this will be 5 over 3 of x, then minus 3 here will go into this 15 5 times. So then 5 times 5, that is 25, then over 2. So 25 out of 2. And then we shall add this a half here, because when it crosses, it becomes a positive. That means our y here is going to be equal to 5 over 3 of x, and then this is minus 25 plus 1, that will be minus 24. Then divide by 2, that will be minus what? 12. So this will be the equation of this line here. Then part B, find the equation of the circle with the center A, which passes through B. So if I have a circle here, the center is A here, and this is 5, 2, and then it passes through B. Maybe B is here, that is 10, then -2. So remember, whenever we are finding the equation of the circle, we need the radius and the center. So the radius is going to be the square root, the radius here. We use these two coordinates here. So the change in x is going to be 10 minus 5 squared, and then the change in y will be -2. There must be a problem here. This one is -1. Pardon me, this one here is -1. The same thing here, -1. Okay, so we have -1 here, then minus these two, and then we square. So what does this one give us? This will be 5, then square 25. 25 plus 9, isn't that 34? So we have root of 34. So the equation of the circle is going to be x, then minus the 5 squared, then plus y minus 2. Remember, we are supposed to use the coordinates of the center here, squared, then plus this. This one is supposed to be equal to square root of this 34. Remember, this one has to be equal to r squared, right? Then altogether, we get our answer as x minus 5 squared, then plus y minus 2 squared, which is equal to 34. That is that. Question 2 is coming from arithmetic progressions. The first, second, and third terms of an AP are a, 2a, and a squared respectively, where a is a positive constant. Find the sum of the first 50 terms of the progression. Okay, so our first term is equal to a. Okay, then to get the common difference, so there is always a common difference here and also here, the same. So meaning we can get the second term here, the second term, which is equal to 2a. So that means the common difference shall be equal to the second term minus the first term, okay, which gives us what? A. You see that? Then also the third term, which is equal to a squared. Again, the common difference, that one is called D. The common difference D shall be equal to the third term minus the second term. You see that? But this one we have gotten it as a right from here. Then is equal to a squared minus 2a. Now if I take this one this side, what shall we have? A squared minus 2a minus a, then is equal to what? 0. We are getting here a quadratic in a. So minus 3a is equal to 0. When I factorize out the a minus 3 is equal to 0. That means a can be equal to 0, or a can be equal to what? To 3. Of course, we shall take a is equal to 3. They say the positive what? Constant. Then this therefore means that the common difference is also equal to what? To 3. And so, because we see it here. Then, what else? We are now going to find the sum of the first 50 terms. So, you know that sum of the first n terms of an AP is n over 2 into 2a, then plus n minus 1 d. So, if we have 50 terms, that means this will be 50 divided by 2, and then 2 times the a, we have gotten it as 3, then plus 50 minus 1, that will be 49, then times the d, which we have also gotten as 3. So meaning here we shall get a 25 into 6, then plus 50 times 3. 50 times 3, you get 150, minus 3, that will be 147. Okay, and then we have 25 here, then times this is 153. Then altogether the answer becomes 25 times 153. That is 3825. 3825. As simple as that. Question 3, part A. Find a set of values of k for which this equation has no real roots. Now remember, when we are solving this quadratic equation, okay, we say x is equal to minus b, then plus or minus to the root of b squared minus 4ac out of 2a. Now, to determine the nature of these roots, we use this discriminant here inside the square root, okay? If it is equal to 0, that means this whole thing is going to go, and then we are going to remain with minus b over 2a. Now, remember when we are solving a quadratic equation, you are expected to get two roots, okay? Two values. So, if this one is equal to 0, now this whole thing is going. That means you're going to get one value. So that is what we call a repeated root or equal roots. You see that? Then, if this one is greater than 0, that means you will be in position to get a square root of a value you get here. So you will use the plus, and then the other one, you use the minus. So that means you are going to get two distinct roots here. But if this one is less than 0, this means that you are going to get the square root of a negative, and the calculator will give you math error. So in the real system, you are not going to have a solution. So you are not going to have real values, but instead you're going to have complex roots. Do you see that? So they have said has no real roots. So then we say for no real roots, okay, b squared minus 4ac has to be less than what? 0. So what is our b? Is k. We square it. Minus 4 times a is 8. And then c is what? C is 2, less than 0. So we shall have k squared. This one will be 32 times 2, that is 64. 64 is the same as 8 squared, not so? This one factorized will give us, because it is a difference of two squares, so it will be k plus 8, and then k minus 8. When I equate this one to 0, I'll get negative 8. Okay, when I equate this one to 0, I'll get positive 8. Please don't do this. Many students do this and they fail. They say k plus 8, then less than 0. They also say k minus 8, also less than 0. Here you are going to get wrong things. Okay, so this is not how we solve quadratic inequalities. Just equate this one in your head. You get what we call the critical values. These are what we call the critical values. So we are supposed to look at a region below this small value, in between the two values, and then above this big value. Okay, so because this one is a quadratic equation also here, the coefficient of k here, k squared, is positive. That means this one is a u-shaped curve. Okay, so this one is going to be our k-axis. Okay, and then where this graph is cutting the k-axis, we have the negative 8 and then the 8 here. These values we have gotten here. Okay, this one is negative because it is below the what? The k-axis. Then this part here that is above the k-axis is positive. So this is positive, and also this one is positive. So that means any value of k that goes this other side, okay, it will have a corresponding y value this side, which is above this k-axis. That means it is positive. You see that? So same thing with this one here. Whatever goes this side will meet with the curve this way above the k-axis. But any value here, when you look for its y value here, it will be below the k-axis, which is a negative. Now, what do we need? Less than. Okay, less than 0, that is the negative part. So this is the one that we need. That means we are just going to write this inequality here, and we say this is negative 8 less than k less than 8. Don't put or equal, because here we don't have the or equal. You see that? So that is going to be our answer. And then part B, solve this equation here. You can actually divide all through by 2. Okay, let's divide all through by 2. We shall have 4 cos squared theta minus, this will be 5 cos theta, then plus 1 is equal to 0. This is a quadratic equation in cos theta, so I can solve it using a calculator. Let's see whether it can be factorizable. You go to mod, then what else do you go to? You go to 5, which is the equation, and then 3 is the quadratic. Then we shall put a 4, then minus 5, and then plus 1. So we get a 1.25. So 1.25, I will leave space, and then I write cos theta is equal to 1, and then also cos theta is equal to a quarter. Then you need to show the examiner the attempt to solve this quadratic equation, okay? So you tell them, you have to show them where you got the what? These roots from. So what we can do is to cross multiply here, okay? When I cross multiply, I'll get 4 cos theta. Are we there? Then bring this on this side. You will have a minus 1 here. That is our factor, which gives us this root. And then also here, just bring the 1 this side, so it becomes cos of theta minus 1, which is equal to 0. Now theta here is going to be equal to the arc cos of a quarter, and then theta here is going to be the arc cos of 1. Now they want from 0 to 180. 0 to 180, cos is positive. All of these ones are positive, and it is positive in the first quadrant and fourth quadrant. So we just put this in the calculator, and it gives us the acute angle, and also here, okay? Of course, here you will get 0. So this one will give us a 0. Then there is also 360, but we shall only take the 0. So what about this one here? The calculator has to be in degrees because the domain is given in degrees. This one is in radians, so I need to first check that. I change it to degrees. This will be 3. And then we have the arc cos of a quarter. And this one gives us 75.5. So we shall have 75.5. So meaning theta is going to be equal to 0 degrees and then 75.5 degrees. As simple as that. This is to 1 decimal place. Question 4 is coming from geometric progressions. A GP is such that the third term is 1764 and the sum of the second and third terms is 3444. Find the 50th term. Okay, the third term is AR squared, which is equal to 1764. And then the sum of the second, so we have AR, that is the second term, and then the third term is AR squared, not so, is equal to then 3444. So don't you think the second term here is equal to 3444, then minus this third term which is given here, so that is 1764. What does this one give us? 3444, then minus 1764, that is 1680. Now the common ratio, okay, remember when we are to find the 50th term, we need the first term and the common ratio. So common ratio R is going to be equal to, it can be the third term, you get the preceding term, then divide by the preceding term. So third term divide by the second term, not so? So the third term, remember it was given as 1764. Then we have seen that the second term is what? 1680. So this one simplified, what does it give us? 1764 we divide by 1680. That is 21 over 20. That is 21 out of 20. So what will be A? Using this one here, okay, our A is going to be equal to 1764, or I can actually use this one here, okay. Let me use 1680, then divide by the R, which is 21 out of 20. So what does this one give us? 1680, then we divide by the 21 out of 20, and This one gives us 1600. Now the 50th term is going to be equal to AR power 49, because remember the nth term of a GP is given as AR, then n minus what? 1 as its power. So our A is 1600, and then our R is 21 over 20. So we power it with the 49. What do we get here? 1600 into 21 out of 20, then to the power of 49. So we get 17474.13301. 17474.13301. That is that. Or you can write it to three significant figures and you say this will be 175. Then these ones you put them to zeros. 17500, like that. Question 5 is coming from transformation of functions. They're saying that the graph with the equation y is equal to f of x is transformed to the graph with the equation y is equal to g of x by a stretch in the x direction with factor 0.5 followed by the translation 0.1. But the diagram below shows the graph of y is equal to f of x. On the diagram sketch, the graph of y is equal to g of x. Now, the first one, they said that a stretch in the x direction by factor 1 over 2. So by factor 1 over 2, that means we are going to get the x coordinate. Remember, if you have y is equal to f of x, and then you get y is equal to f of then 2x, this is what we call a stretch by factor 1 over 2. Okay, this one you put it down like the graph is going to diminish. Okay, so you have 1 over 2 then in the x direction. So you get the x coordinates. Okay, now we are going to multiply this one. The x coordinates are going to be multiplied by a half. Okay, that's the factor. Okay, now let's go. Here the x coordinate is 1, so times a half you get 0.5. So it will be here. Not so? So I will first put it here. A half. Then we go to this one here. The x coordinate is 2. Then times a half. Then you will get a 1. So I'll put it here. The x coordinate here is a 3. Times a half you get 1.5. Not so? And 1.5 will be here. So I'll mark this one. Then after that, we also have this one. The x coordinate is a 4. And then times a half. So we shall have it here. So I'll put this one here. Of course, here the x coordinate is 0. So times a half, again, it remains as 0. Okay. Then the next thing we are going to do, translation 0.1. That's the vertical translation. So each of them, I shift it up by 1 unit. Okay. That is moving up by 1 unit. So meaning I will move this one here by 1 unit. It will be here. Okay. This one moves there 1 unit. Okay. So I'll take away this one now here. Also, this one will move up by 1 unit. It will be there. Then what else? Even these 3 here, we move them up by 1 unit. So we shall have this one here, and also this one here. Now I can take away these ones here. And then you get your ruler, please. Don't use your free hands. Because you are given straight lines, you also draw straight lines using your ruler. So this is what we are going to have there as our final answer. Then part B, find an expression for g of x in terms of f of x. Okay, just like I said here for the first one. So we shall have y, which is equal to f of 2x. Okay, this one is the one that tells us that we are having stretch. So this is for stretch by factor a half parallel to x-axis. Okay, then we have y is equal to f of x, and f of this 2x here. Then we are adding a 1 here. That will be a translation by vector 0, 1. So this has to be our final answer. Question 6. The equation of the curve is 4x squared plus 20x plus 6. Part A. Express the equation in the form y is equal to a, and then x plus b bracket squared plus c, and then where a, b, and c are constants. So this is completing squares. You can do this in 2 ways. You choose the one that is simpler for you. So one, I'm going to use direct completing squares. Okay, first of all, we have to make sure that the coefficient of x squared here is a 1, and here we see that it is a 4. So what do? Because this is an expression, we are supposed to factorize. Okay, so I'm going to factorize, put the 4 outside, then you have x squared, and then plus 5x. Okay, I can leave the 6 outside. I just need these parts, these 2 terms that have gotten the x. Okay, now suppose we have something like this, x then plus b squared, and then I do it, I expand this one here. It will give us x squared then plus 2bx then plus what? The b squared. Now I only need this part that has got these 2 terms that have gotten the x in them. So take this one this side. We can have x plus b squared here, then minus b squared when we rearrange. So this one is going to be x squared then plus 2bx. Okay, now I want you to look at the coefficient of x here, which is 2b, but then it was divided by 2 to give us a b, not so? Then that b, they put it here and also here. Do you see that? So even here, what we are going to do for, you just get the coefficient of the x here, you divide it by 2. So you'll have 5 over 2. You see that? Then you square it, then you pop it out here as a square. Like that. Okay? But then there is a 6 here. So when you expand the whole of this, you will actually get this one here. You see? Okay, now let's proceed. We now open the brackets. So this 4 will multiply with this x plus 5 over 2 squared. And then here we are having 25 over 4. Then we are still multiplying with this 4 that is coming from here. Then we add a 6. Then what does this one give us? 4 x plus 5 over 2 squared. Of course, this one will go. And then you have minus 25 plus 6. Isn't that negative 19? That is negative 19. So that becomes our answer. And they said a, b, and c are constants. They didn't say they are integers. Integers are whole numbers, positive or negative what? Whole numbers. You see that? But I can see the 5 here. Okay, 5 over 2. That one is also a constant. So we just leave it here like that. But alternatively, if completing squares this way is a problem to you, you can expand and then equate coefficients. So we shall say that this one here, the equation given here, is actually the same as, then you bring this one they have given you, it is a into x plus b squared, then plus what? C. So what are we going to do? We are going now to expand. Okay, so let's expand the right side. This is a. Inside here, just like I told you here, you're going to have x squared, then plus 2bx, then plus b squared, and then there is a plus c. So meaning that when we open the brackets again, when we multiply through by a, we shall have ax squared, then plus 2ab of x, then plus AB squared, then plus C. So now here we equate coefficients. The coefficient of x squared here is a 4, and here it is a. So meaning a is equal to 4. You're done with that. Then you go to the coefficient of x here. It's a positive 20. Then 20 is equal to the coefficient of x here is 2ab. So 2ab. So meaning b will be equal to 20. Then we divide by 2a. But a is a 4. You see that? Then 20 divided by 8. By 4, you get 5. By 4, you get 2. So that is the 5 over 2. Okay. Then after that, what else are we getting? You go now to the constant what? Term. So the constant term here, we are seeing a positive 6. Not so? So we have 6 here, which is equal to ab squared plus c. All of these ones that have not gotten a what? An x on them, that is the constant term. So our a is a 4. Our b is 5 over 2, then squared, and then plus what? C. So this will be 6, then minus. This will be 4 here, then times 25 out of 4. So this one goes. You see that? This one will give us a C. And C becomes negative what? 19. You see? So this simply implies that now you get this. Okay? Just bring it here like that. And then where there is A, you put its value. Okay? B and C. So our A is a 4. Our B is 5 over 2. And then our C is a minus 19. So you put minus 19 here. So any of the two methods works. Okay? Whatever you want. So that is that. Then part B, hence solve the equation. This one here. They said hence. So begin from where you have stopped. I know some of you can put this one here, and then you have a quadratic 4x squared, then plus 20x. Then I think this one will be minus 39 is equal to 0. Then you use the quadratic formula to solve that. You will get 0 completely. So what you are going to do, begin from where you have stopped. This one here, just slide it and put it down here. You have 4 into x minus, because this one is the one that we have expressed here, not so. So x plus then 5 over 2 squared minus 19. Okay, then this one is equal to what? 45. Then you'll have x plus 5 over 2 here squared, put the 4, and then this one is equal to 1. You bring this one this side, what do you have? 45 then plus 19. This one will give you 14. Take 1 here, and then this one is 64. Okay, so we have 64 there. Then we can divide all through by 4. So you'll have x plus 5 over 2, and 4 goes into 64 16 times. Okay, and then from there we take the square root. So when we take the square root, we shall have this one plus or minus 4, because remember, when you take the square root, you put plus or minus. You see that? So that means x is going to be equal to 5. Actually, it will be a negative 5 over 2, because here it is positive. When it crosses the equal sign, it becomes what? The negative. Then plus or minus 4. So meaning x1 is going to be, you consider the positive, and then x2 you will consider the negative. Okay, so which values then are we getting here? So here x is going to be 2 times 4, that is 8. Then 8 minus 5, that will be 3. So we get 3 over 2. Even when you use the quadratic formula, this is not what we are, I mean, this is what you are going to get. But remember, they said what? Hence. So we are supposed to strictly use this, like I said before. Okay, then here 2 times 4, that is 8. So minus 5 minus 8, that one will give us what will that give us? Negative 13. Yes, negative 13 out of 2. So that is that. Then part C, sketch the graph of y is equal to 4x squared plus 20x plus 6, showing the coordinates of the stationary point. You are not required to indicate where the curve crosses the x and y axes. Now, this y here, we have seen right from here that if you can check again, this is this one here, right? So we have 4 into then x plus 5 over 2 squared, then minus 19. So that means the vertex or the stationary point is going to be equal to, equate this one to 0, and then you get the value of x here. That will be minus 5 over 2. And then the y coordinate will be this one, because if this one disappears, this is what you're going to get, right? So that is negative 19. Now, when we are sketching this one, first of all, the coefficient of x squared is a negative, okay? So if it's a negative, then we are going to have a U-shaped what? Curve. So we shall have a U-shaped curve. In fact, let me try to put the axes here, and then we can locate our values here. So we are not supposed to show where the curve crosses the x and y, those points. We don't need them. Now this one is a U-shaped curve. So where is this one here? Negative 2.5 will be this side, and then negative 19 is this side, not so? So that means, let me actually try to put this one around here, and then also this one there. Then we shall have a U-shaped curve. So when you actually try to see where it crosses the y-axis, on y-axis x is 0, not so? This whole thing can go, then you will have a 6. So that means when I'm drawing, it should cut this one here. You see that? Y-axis. Then the turning point will be this side. This is negative 2.5, and then the 19. So now let me draw it. Well, so it will be like that. That is that. Then you indicate the what? You indicate the stationary point, negative 5 over 2, and then negative what? 19. So you can tell them that this is negative. Okay, this is negative 19 here, and then this is negative 5 over 2. This is a 0, and that is that.